How's it going, guys? Just want to give you a quick video introduction here. Just going to bring you along and show you what I've got done on the mill so far. As I said in the channel intro, I have worked on it quite a bit already without documenting it. So I just want to show you that and catch you up, and yeah, let's get to it. Yeah, so this is the main part of what I've got done so far, and I'll just kind of give you the rundown, and there's a lot still that has to be done with this, but it's just kind of in mock-up. So anyways, you'll see that the main structure is this 1/2-inch plate. This tube is bolted with 5/8 bolts to the back side of this plate. That tube is just to give the plate rigidity. You know, this tube has, the sidewalls of this tube give the plate a ton of rigidity. And when I'm ready, this is not only going to be bolted on, but stitch welded right in this radius, just a few stitch welds. I want to minimize welding to minimize contraction and stuff. So yeah, so that's going to get welded to that. And more than likely, most of the tube is either going to be filled with sand or epoxy granite. Ideally, epoxy granite. It depends how expensive it is. It depends how hard it is. There's a lot of factors. It's not something I'm thinking about quite yet. But one or the other, this tube and a lot of the structure is going to be filled with that. So yeah, you can see these big, I believe they're like 1.125". Excuse the mess behind. That's house stuff. We've moved pretty recently. So anyways, these are big blocks here, and these actually came off of, you can actually see this one. You can actually see right here would be where a lathe tool would go. And that was actually big blocks off of an old brake lathe. And I've tried to use as much material as, use material as I can. So that's something I had. So I made them work, and they are actually bolted. One big bolt through here, because there was already accommodation for that. Then there's 2 bolts that come through the plate this way, and the block's threaded. And there's actually 2 pins that actually indicate it. 2 5/16 pins that set it, and that's the same on both ends. And basically, this right here is an accommodation for the towers that hold this main gantry up. So so it'll set, one face will set here and be bolted, which I don't have bolts there yet. Be bolted, and then it'll actually be bolted through the side here, through the side of this. Actually, I can't remember if I'm going to actually bolt through one layer of the tube into this. I'm not sure right offhand, but one way or the other, it'll be attached to the side. So anyways, that's that. So you will see these are big HSR, is that right? Or no, LH25 NSK rails. So they're 25 millimeters, so they're bigger than like what you see a lot of people use. You see 20 a lot, kind of standard. But I got a really awesome deal on these, and they're brand new basically, and they're really sweet, and I'm glad they're heavy. I'm glad they're one size up. So that's cool. You can see here, you got the standard 1605 ball screw. These are the couplers that I went with, which are basically a double diaphragm flexible coupler. It's got the stainless discs in it, and that was after looking at some different designs and actually hearing someone, a YouTuber, talk about couplers. They recommended these, and these are really nice and robust. Of course, you'll see this motor looks kind of small, but actually it's not. It's short is what it is. It's a NEMA 34, a short body NEMA 34. So they're actually 828 ounce motors. So they're pretty big actually. But and you can see it's a dual shaft, so I can actually put a handle on here if I want to, if I so want. I actually got an awesome deal on these, on the whole kit from they are a Chinese company called Long's Motor. And I actually did some research into their company, and they actually have some ISO certifications and stuff. So I was pretty confident after doing the research, and actually the kit normally was somewhere close to like $400, I believe. And I think I got it for like $200. It was like half. And it wasn't long. I went back. It was an eBay listing. I think they are kind of odd because they're a short NEMA 34. A full size NEMA 34 is like 1,200 ounce or somewhere in that range. So I actually didn't plan. I actually planned to go with about a 600 ounce motor, But so I got these 800 ounce, and you know, I'm glad. I think it'll be perfect. So anyways, that's the motors. There'll be more on all that stuff later, but it's just a quick rundown. Like I said, this is in mock-up, and you'll see there's no machining on the face of this, but there will be. After this gets welded on, and there's actually going to be 2 little pads welded to the back side of this that are about 18 inches long, so I can actually machine those and flip it. And I'm going to have to, on my mills, not long enough to machine this whole this long of a section, so it's going to be scooted once. And I'm going to use these pads welded to the bottom to do that. These are all the 1/4 bolt holes. I tapped them all with a spiral flute tap on the mill, just actually using the mill, and maybe if I have a chance I'll show you guys how to do that sometime. There's some other videos you'll see online and stuff, so that works pretty cool. Spiral flute tap is just the way to go. I mean, if you've never used one, you got to get some. So basically all I'm going to do when I machine this is just machine these strips where this bolts down, and machine these sections where this bolts down, because there's no reason to remove material. It's more chance for movement in the piece, and there's no reason to face off the whole plate. It's just pointless. So I'm just going to do these strips and you know, some pockets around here, and that's it. The only tricky part about that is when I flip it to mill this surface, I do have to mill this surface because the tube sets against that and this block sets against it. So this whole surface on the back side has to be flat and parallel to these surfaces where this will be milled. The only caveat to doing it the way I'm talking is I'll have to find some 1-inch gauge blocks or something. These are about 1 inch, in order to set it up on when I flip it and keep it on the milled sections. Or even maybe I'll make the pockets big enough here and I can use some 1, 2, 3 blocks here and here. That's probably what I'll do, actually. So anyways, you can see here is the Z-axis, and it's 3/8 steel, and I've got some pictures I'll try to throw up, but these are 1/4 inch pads that were welded to it, and there's actually 3. The reason there was 3 was to assist in machining these down and getting everything flat. So basically I welded these on. I set the pads on 3 very small surfaces, one here, and one here, under this pad, and one side of this pad, and right in the middle over here, and I clamped it in those 3 places. And what that does is 3 points make a plane. So instead of welding this on and trying to suck all this pad goes all the way across, 1, 2, 3. So instead of pulling that down to the table, there's very good chance that you will actually pull a corner down or part of it down or whatever, and when you let it off, it will no longer be straight. So that's something you really got to work on and really got to nail down. So basically, I put those very small spacers, 3 of them, bolted it down, milled these. This is 1.5 inches wide, I believe. Just hot rolled steel bar that I actually milled out for clearance because these are bolts. And that was also, you can see these are TIG welds, stitch welded all along there. No reason to solidly weld it. It's just more heat contraction. So anyways, so I basically put those on there, and then I milled these just flat. I didn't try to get them to depth yet. Flipped it back over, then milled these pads, and then flipped it over again, indicating the side every time. Well, actually, I actually only had to indicate it the last time when I did the bolt holes. But anyways, so yeah. And so you can't see it here, but under this, where the ball nut housing goes, is a little square pocket that's milled the exact depth and distance from here to that milled pocket to where the nut housing sets. And yeah, that's part of the reason for the pads. That's the main reason where the pad started, was just to get the distance correct between where they bolted to the linear bearings and where the nut housing bolts to the back of the plate. There's different ways to do that. Same thing up here. You'll see that these pockets were milled for the ball screw ends, and these pads here, or these blocks, or these strips, this bar, steel bar, was milled. Again, it had to be exactly the right depth from here to here. And when you slide a ball nut housing on this, and you put a straight edge across there, it's perfectly flat. So when the Z plate gets bolted to these rails, the ball housing will be bolted directly to that. Let's see here. And I'll say there's different ways to do that, and the way you see it done a lot is basically the rails are just bolted flat to the plate, and then whatever the front plate is has the spacers on it, basically, if that makes sense. So it has like a big cutout right in the middle for the ball nut housing to go in. This is just like the opposite version of that. I felt like this is a better design. I don't know if it's as compact or if it really matters, or if it's really going to make a difference as far as compactness, but that's the way I wanted to do it, so that's what I did. And you can see these are 1605 ball screws, common Chinese ball screws. I will say I'm really impressed with the quality. I mean, and especially the price. I mean, we'll see on performance. I don't know about the performance yet, but I'm super impressed with just the visual quality of it and the feel, and yeah. So these here are, I forget between which ones they are. Yeah, these are THK HSR 15s, and these are 15 millimeter rails, smaller rails for the Z-axis. So yeah, I got those on eBay used as well. They weren't quite as perfect as these, but they turned out pretty good. The end seals are no good on them though, and honestly, I'm gonna have to buy some end seals, and they're actually, I think it's $40 to put the end seals just on these. So I didn't save much money on these in the end, but I learned a lesson after that. These are perfect. These are basically brand new. So yeah, and also I'll explain this motor mount here. This motor mount was actually, I started with a 90-degree mount, NEMA 34 mount, and I just cut it in half and basically made a straight mount, added these side pieces for rigidity. You can see these are countersunk screws, kind of what I would call rosette welded. It's not going to focus, I don't think, but anyways, they're TIG welded. They're TIG welded in here. They're beyond the surface because down here they would hit the plate. And this was kind of an afterthought, this design. So one issue I did run into was there's not enough space here to actually put a nut on. There's not enough space to actually, the nut hits this part here. So I found these, what they call Allen nuts. And they're basically just a threaded portion with an Allen, socket here. So you can use an Allen key, and they're just a nut. And they call them Allen nuts. They're pretty slick, really slick actually. So yeah. Let's see, is that about it? I think that kind of catches us up. Like I said, there's a lot to do still on this. A lot of the milling and stuff needs to be done on this part, but it's just in mock-up. And everything, you can see, of course, this, there's these screws that hold this on aren't tight, so you can see that. But you can see it takes no effort, and it's, I don't know if you can see it moving, but I mean, I can spin it just with 2 fingers, super easy. It just glides right across there, so I'm really happy with that. I mean, it's just butter smooth. And I was afraid, I was a little bit leery of all this weight hanging over, but these big rails are just, it's like nothing's there. So I'm happy with that. There's one more thing that I wanted to show you guys that I've been working on. This here is, you may think, what in the world is this? But so this right here is a fixture, and basically you'll see in the CAD drawing a lot of the bottom, the base structure of the machine. It's hard to explain, but all of these the center pieces and the ladder assembly that the table rails go on and everything, they have pads. They have 1/2-inch pads welded to the bottom of them. So all this is this correct bolt pattern for the 1/2-inch pad, and all this was set with actually a 246 block at 90s, and these were milled on the side and the bottom, both of them, and they were set up so that the tube comes in. That's 2x3 tube comes in just like this and centers these holes perfectly, and the plate will be pre-drilled and cut and bolted onto this first. You slide the plate in, or the tube in, and I'll C-clamp it here, C-clamp it down to the table here and at the back, and that'll allow me to weld those end plates on all of them. I think I have 8 total end plates to weld on, and it'll keep them really, really nice right angles and keep them really good. You know, so I won't have to do much milling. I'm hoping, because all of them fit between, you know, they have to be all 4 separate tubes that have a pad on each end have to be the same distance. They have to be the same length. So hopefully, I just don't want to have to take a lot off into these 1/2 inch plates. Hopefully I can just take like 10 thou off of all of them, and it won't be no problem. That's why I'm going through all the effort to do this, because I want it to minimize the milling, because I'm going to have to get a big, heavy, huge like 3/4 mill bit with like a 3-inch length of cut, and I've done that before, and it works with a really good sharp new bit, but it's pretty hard. It's a, you know, there's a lot of deflection. But anyways, that's the plan. Oh, and this table, I'll just explain. This table is just part of one of those little, I don't know, what do they call them, sliding compound tables that you'd put on a drill press to kind of sort of turn it into a mill, or function sort of like a mill. And the thing wasn't flat at all, so you can see I had to actually face mill it and machine it to get it flat, because it was bowed like this. But I did that, and I machined these on top, or the bottom and the side. Drilled the bolt pattern in, and used a 246 block to set these, you know, to set all this properly. Basically centered it with scribe marks this way, and then used this block and made sure it was square to that face back here, the end of it, and then bumped this up against the side of it and clamped it to it and got it all set, and then bolted it all down. Yeah, so that should work really good. I think it's going to be pretty crucial to really, it's actually going to save me a lot of work in the end, I think. So anyways, let's see here. This is just the little mill that I'm using, and like I said before, it's actually really accurate. I can get it's trammed in really well. Anyways, it's not nothing too impressive, but it's getting the job done, and I'm actually pretty happy with it. So kind of a mess over here, but let's see. Oh, this is another really handy tool that I've been using. On the stuff I didn't tap on the mill, like this, I only have a 1/4 inch spiral flute tap. That's the only one I bought right now. So all the other stuff I've been using traditional taps and this, and these are awesome, really awesome. So yeah, I think that's pretty much it. It pretty much catches us up. I will go ahead and show you. This is the 2 by 3 1/4 inch wall, super heavy tube. This is just a 2 by 2 that will kind of connect the legs together and everything. This back here is a 1/2 inch plate. That's where all the pads will be made out of. I've got some extra tube and some more tube down there and some stuff. There's going to be some stuff added to the design later. Some basically triangulation pieces that hold the towers, keep the towers good. But anyways, boy, I think that's it. Here's my TIG welder, a Miller Econo TIG. Great machine. It's a transformer machine, but I really love it. It works great. Yeah, guys, I hope you enjoyed that. As you can see, I've got quite a bit done so far. I'm going to go ahead and bring you guys along as I finish up the build and as I move forward. There's some changes and some additional stuff that'll be added as it's built that aren't in the CAD design. But for now, you know, moving right along. I did want to show you guys something that I just got in the mail. This is the Z-axis main plate, the sliding plate that the actual spindle will be mounted on. It's a 3/4 inch thick, 7 3/8 by 11.5 long approximately. And the reason I wanted to show you guys this was because it's something that I didn't really know much about, but I discovered it, and it makes it easier, and it's a very useful thing anyways. This is not just aluminum plate. This is actually precision cast aluminum, and it's I believe it's Blanchard ground, so it's really quite precise. I don't have my mics here. I have a nice set of Mitutoyo mics at work, and I need to bring one home to mic it out. And I can also check it. My dad's got a surface plate, granite surface plate, that I could check the flatness of it. But with a dial indicator, you know, a vernier, it looks, you know, it's really, really good. So I'm hoping I won't have to do anything to this. So you can, the cool thing about this is you can find this stuff on eBay, and I searched for a while to find the size I wanted, and I actually ended up getting the exact size, the piece I want. So what these are cutoffs. They're drops off of big sheets. They sell these in 4x8 sheets, I believe, 4x8, big sheets. They're used for fixturing and tooling and a lot of things like that. And the great thing about this as well is it's very stable. It's more stable than regular aluminum. If I were to machine it, it stays flat better. And the cool thing is, I got this drop for 32 bucks, 3/4 inch thick, perfect. It's already you know, ground on both sides, and I'm hoping that that's perfect enough, and I think it will be. I really do. So to me, that's a pretty sweet deal for something like that. It's a very stable piece of aluminum. It's really good for a machine tool like this, or fixturing or anything like that. So that's a tip for you guys. Just look up precision cast aluminum, and that's how you'll find it. Otherwise, you won't. It doesn't come up. It's kind of one of those things. You find the right search term, you can find it. So that's a tip for you guys. I've also got a few little things done since I filmed the last part, but I'll just keep you guys updated in the future on that. Appreciate you guys watching. You know, if you like it, give me a thumbs up, and, you know, stick around, subscribe, so you can, you know, get all the next videos that come through. So I appreciate it. Have a nice day. I'll see you on the next one. Thanks. Bye.